Hello, I'm John Gertz, the SETI theorist, and this is a series of videos on the subject of reinventing SETI. This video is the second one on the subject of probes, and we're entitling it Nodes. In the last video, I hope to demonstrate or prove that if ET exists and has a desire to communicate with Earth, then its best strategy for doing so is to send to us physical probes, presumably robotic and AI probes, rather than to try to communicate through star to star direct communication using electromagnetic waves. But there is a problem with that. The communication would be only one way unless ET has a way of getting the information back to its home planet. That's a formidable challenge. The transmitter that it would need to do that, if it was going to do it directly, and if its progenitor or home system is a modest 100 light years away and the galaxy is 100,000 light years from one side to the other, it would need a transmitter vastly larger than our largest radio telescope, which is the FAST telescope in China, or Arecibo, which is recently defunct, but had the largest transmitter in the world. But it would need one much larger than that. And it would have to schlep that transmitter across the galaxy to our solar system with it. That's a formidable challenge. And frankly, with a telescope or with a transmitter that large, we might be able to see it almost as a naked eye object, if not a naked eye object, one that our telescopes might have picked up. But there is another way that they might be able to do this. In the figure on your screen, you will see two modes of communication. One is direct star to star communication, the straight line, and one is a jagged line that goes through relay stations or nodes planted around intervening stars. There may be these kinds of relay or repeater stations or nodes, communication nodes, orbiting every star, such that the transmitter that would be needed from Earth to the nearest star would be considerably smaller, and the amount of energy necessary to power that transmitter considerably less if it does that. It's still large, however, but it's not formidable. And there are ways around the problem that even then you need a large transmitter. We'll discuss that in a second. In the second illustration, we'll show it. I'm showing here how a nodal system might work, where information from multiple civilizations is being coalesced through the nodal system and being sent back to the progenitor civilization, the progenitor alien civilization. In the next illustration, you can see how information could go back and forth among all of the civilizations. They can all be hooked up to this galactic internet. As information is constantly loaded up through this nodal system, it grows, much like information in the Library of Congress grows from year to year. And that's irrespective of whether the authors who have contributed their books to the Library of Congress are still alive. The information continues to grow. It's the same thing with the nodal system, that it doesn't really matter whether a civilization exists or has gone extinct. Once they've uploaded their prosaic encyclopedia, then that encyclopedia becomes part of the body of knowledge that belongs to the entire galaxy. Information that is stored in multiple nodes now becomes redundant. And being redundant, it doesn't then matter whether a particular civilization not only goes extinct, but its vicinity is destroyed, such by a nearby supernova, a gamma ray burst, or some other tragedy. Whether one system of nodes or one area of nodes is knocked out is not going to hurt the whole body of knowledge, which is diffuse across the entire galaxy. The information, as you can see in this next information, could be further magnified and concentrated if the nodal system uses basically a 2 probes per star system, where the first probe orbits in the inner solar system, presumably near our own planet, while its sister probe can be at a place that, according to Einstein's theory of general relativity, would be suitable for bending and magnifying its transmissions This gravitational lens, as it's called, exists for a star the size of our sun, approximately 550 times the distance between the Earth and the sun, or what are called astronomical units, out. So a probe located in the exact position of 550 AU out and exactly opposite, say, Alpha Centauri, would magnify the message to and from Alpha Centauri by a factor of perhaps a million, solving the problem altogether as to the size of the transmitter that would be necessary to move information. Alternatively, if you look at the next graph, there could be repeater nodes strung out like a string of pearls between one star system and the next, so that there could be perhaps one of every tenth of a light year or a hundredth of a light year between us and Alpha Centauri, and Alpha Centauri is the nearest star to Earth, or that system is a three-star system, is the nearest star system to Earth, and at a distance of about 4.2 light years. So if you split that distance up 100 times with repeater stations, you can again lower the initial amount of energy that's required, or the size of the transmitter that's required. So the question now becomes, where in our solar system might we find these probes? First of all, there could be thousands of them in our solar system, while only a few of them, or maybe only one of them, is actually active. The others could be dormant, basically space junk from probes that were sent millions of years ago. The first probe that we might actually physically find in our solar system could be inactive. It could be space junk. But an active probe could be anywhere. There are places I would favor looking if I went to look for one, but truthfully, they could be in any direction. We could look, I would suggest, around the sun, within the orbit of Mercury. There are two reasons why that would be a very good spot for a probe to locate itself. One is that it is obviously an energy source nearby with the sun. The second reason is that it becomes very easy for a sister node or probe around another star system to be able to locate it. All that's the protocol could be, if you want to find a sister node, just point directly at the star and it's somewhere around there. So if the beam of transmission, and all electromagnetic beams may start as a pencil thin if they're a laser, but they'll spread out gradually. And so that beam may start as a pencil around Alpha Centauri, but could broaden to cover a fair distance around our sun, and thereby illuminate its sister probe near the sun. So that would be a one place to look for a probe. Another place might be on an asteroid. An asteroid would be a good spot because there's still enough solar energy to power photovoltaic sensors or energy supplies that the probe would need. The probe might be able to dig into the regolith of an asteroid for protection against radiation and micrometeorites. So the surface of an asteroid might be a logical place for a probe to hang out. There are also materials there might be useful to a probe for self-repair or for build-out of capabilities. And a matter of fact, I'm going to ask the question, how do we know that all asteroids are in fact asteroids? The only thing we really know about an asteroid is it's a point of light. And unless we visited it, most asteroids, and especially small asteroids, are really just known to be points of light. We only assume that they're all asteroids without any hard evidence to that fact. It may be that one or another asteroid is not actually an asteroid, but an alien probe. One bugaboo of SETI observations is what we call the candidate signal that disappears, or a transient signal. The most classic example of that is the so-called WOW signal that was received by the Big Ears radio telescope in Ohio in, I believe, 1974. That had all the features that we might suspect of an alien signal, except that when astronomers went back to look for it again, they couldn't confirm the signal. It had disappeared. Well, one thing that I would ask about that signal or other transient candidate signals is what else was in the field of view at that point of time? Was there an asteroid there? Obviously, if we go back and look at the exact same spot as SETI researchers have done, to go back and look at the area of the WOW signal to see if they find anything there, and nothing, and have not to date observed anything. But if the signal was actually coming from an asteroid or a probe that otherwise was in motion or in orbit at that time, then it's not there anymore in that field of view. It's somewhere else. So whenever you have a transient signal, you want to be able to ask, in the first instance, was there an asteroid or some other local object in that field of view? And if so, where is it today? And that's where you want to look again. If you observe a transient signal in near real time, you want to take your telescope and slew or move your telescope in a gradual outward going spiral so that you could figure out maybe, and catch up to the probe that was there and maybe still signaling. But I'm going to tell you the truth. In my opinion, when a probe finally does signal to Earth, and as I said in my my last video, and does so in the Queen's own English, perhaps, it's going to pass what I'm going to call the interlocutory test. And by that, I mean to say it smacks you right between the eyes. You're not going to need the world's most powerful telescopes to find it. It may take over FM 88.5 or channel 2 on your television set. It may be observable by one and all. If it's a laser, which it may very well be, it might be the brightest object in the night sky. It would be instantly recognizable as an alien laser because, number one, it's monochromatic. Stars are broadband in their light, and they radiate light on all frequencies, whereas a laser only broadcasts or transmits light in a narrow frequency. And it'll be a star in a place where a star never had shown before. It might be the brightest star in the sky, so it's going to be immediately obvious it's an alien laser. So until that day, however, it may be a fool's errand to try to find it. It may have masking capabilities. It may not. If it decides that it doesn't want to be discovered, it may well not be available to us despite our best efforts. So further, I have to warn us that robotic probe may be judging us. It may be viewing our sitcoms like I Love Lucy and getting a good laugh, but at the other time it may be appalled by our nightly news and have come to judge us as a wretched and miserable civilization. It may be here to play judge and jury. So if the world is well nigh, it may not be at the hands of a deity, but at the hands of an algorithm embedded within an alien robotic probe. To further add to the despair, we may not be that easy to decipher, or the probe may not have the onboard capability to fully decipher what it's learning about Earth. In consequence, it may have to send information back to its home planetary system, its home base, for deeper analysis or instructions on how to proceed as to whether to open communications with us, to observe us for yet longer period of time, or to destroy us forthwith as a danger to the peace-loving civilizations of the galaxy. If that progenitor civilization is 1,000 light years away, it may be 2,000 years before that alien probe receives instructions back again, and we may be waiting here millennia to make contact with the probe that is sitting here right now today on an asteroid or someplace else in our solar system. However, I don't want to leave you with despair, and give you a sign of a little bit of hope, and that is that ET would destroy us only with great reluctance. It needs us. A question can be posed as to how could any one alien civilization build all the billions of probes and repeater nodes and stations that are necessary to run the galactic internet and maintain it all? And the answer is it can't. No one civilization could do that. it's going to need our help. And that is, in fact, our biggest bargaining chip. We don't need to trade information with ET. ET has already learned everything it needs or what wants to learn from us. It's uploaded everything we have through our television and radio signals and our internet. Unfortunately, we have nothing we can trade with them in that regard. However, they do need us to maintain that galactic internet in our sector of the galaxy. And as a consequence, they can use our factories to build probes and nodes and so forth. And they can use our large land-based telescopes to establish communication with nearby nodes as well. So that's our bargaining power. And we should give it only to ET with some actual business sense and trade for them valuable information and valuable science and so forth. Again, I'm John Gertz. You can learn more about me at johngertz.com, and I'll be continuing this series of videos on reinventing SETI. I hope you'll tune into my next one. Thank you very much.